Okay, so 5-4 uses a lot of prior knowledge and something new. And so I have given you this goldenrod sheet that has all of your trig identities and other formulas on it, right? Front and back. You're going to learn all of this through chapters 4 through 6. That's what this covers. A good portion of what your final exam is over also, with a few extra chapters mixed in. Yes?
No unit circle, but the other notes? You can use unit circle on the quiz?
Oh, on that quiz. You can use any notes that you want to. Okay. All right, so today you're going to be introduced to the sum and difference formulas. So essentially we're not doing a whole lot different. We're combining everything that we've done before, just using 6 different formulas. Okay? Then on here I've also put your special right triangles. They're going to come into play. I'm going to put them into my coordinate grid where they belong. We still have to pay attention to where our angles are in the coordinate grid. Let me find my missing notes. Yes, you can use a unit circle if you want. Oops, those would be the wrong notes. Hold that thought. Where'd they go? I had them all. This is what happens. Algebra messes everything up. Here's one. Oh, there they are. And then hopefully my voice will hold out. We'll see. All right, so let's look at this right here. You are to find the exact value of the cosine of 75 degrees without a calculator. Now, everything up to now, I've been asking you to find the cosine of, 30 degrees, right? How come I hear talking? I'm talking. There you go. This is not one of the angle measures that are in your special right triangles. It's not a 30, a 60, or a 45-degree angle. It's not 0, it's not pi, it's not 90 degrees, it's not 270. So what do we do in that case? Well, we came up with this, not we, some smart person came up with these sum and difference formulas to alleviate that situation. So look at the cosine of 75. I'm going to zoom in. How can we change 75 by using 60, 30, and 45s? By either adding them together or subtracting them.
75 minus 45 is 30.
Say that again?
75 minus 45 is 30.
Okay, so she said 75 minus 45 is 30. So how about 45 and 30? Because we have to use both angles. Both angles that we use here, or here, they have to be 30, 60, or 45 in some form of sum or difference. So 75 is equal to 45 plus 30. Would you all agree with that? Mm-hmm. All right, so we are going to replace cosine. We're going to replace 75 degrees with 45 degrees plus 30 degrees. Or you can have 30 plus 45. It really doesn't matter. I'm going to pull out just a little bit so I can use my triangles. Which formula are we going to use above? This one right here, correct? Mm-hmm. So that means we're going to take the cosine of the first times the cosine of the second, and then a minus, it's the opposite sign of what's in the parentheses, sine of the first times the sine of the second. So we've got, this equals cosine of 45 degrees times cosine of 30 degrees minus sine of 45 times sine of 30. Isn't that what it says to do? So using your special right triangles above, 45. Here we go. What's the cosine of 45? 1 over rad 2, but we should know that it's rad 2 over 2, right? And you really probably want to use the rad 2 over 2 rather than the 1 over rad 2. So we're going to replace cosine of 45 with radical 2 over 2 times cosine of 30. So here's our 30 degrees here. What's the cosine of 30 if that's my degree of reference? Rad 3 over 2 minus, what's the sine of 45 if that's my degree of reference? 1 over rad 2, or we want to use rad 2 over 2 because it's rationalized, right? Rad 2 over 2 times What's the sine of 30? 1 over 2. So times 1/2. Then this equals, you can only multiply what's under radical to what's under radical and what's outside of radical to what's outside. So doesn't this become radical 6 over 2 minus, and this is just radical 2 over 2. You don't want to leave your answer that way. Aren't they both over 2? Mm-hmm. So your final answer is, since they're both over the same denominator, radical 6 minus radical 2 all over 2. You cannot cancel the 2 into the 6 or the 2 into the 2 because what's inside of a radical cannot associate with what's outside of a radical. They cannot reduce. This is your final answer. Yes?
Well, I'm just kind of confused. Like, why can't you just subtract them?
Because I don't know what the square root of 6 is, and I don't know what the square root of 2 is.
You're right.
I could use my calculator and do that, but they said they wanted the exact value, so I have to leave it in radical form.
Yeah.
And you can only add and subtract radicals that are like radicals, so this would be no different than having x minus y. You can't subtract those, so they'd stay there. Does that make sense? All right, so then let's look at the second example. So we're going to have a couple of steps with this one. Find the exact value of the sine of pi over 12. Huh. What degree is pi over 12? We have to find it. How do we do that?
180.
So we're going to take pi over 12 and multiply it by its conversion equivalency. Remember, it's 1 over, or pi over 180 or 180 over pi. Since I want my pi to disappear, pi goes on the bottom and 180 up top. So the pi's cancel. Does 2 go into 180? Yes, because it's even. How about 6? What's 1 plus 8 plus 0? 9. So that's divisible by both 3 and 9. So since both 3 and 2 go in there, 6 goes in there, right? So 12 goes in here once. 12 goes in there how many times? Yep. So you end up with 15 degrees. So 15 degrees is not one of our special right triangle degrees. How can we use 45, 30, and 60 to get 15 degrees? 45 minus 30. So then it's sine here, right? So step 2, we're going to replace pi over 12 with 45 degrees minus 30 degrees. And so that equals, use your difference formula for sine, and your sine and your cosine alternate. So it's the sine of the first one, so sine of 45, cosine of the second, 30. It's the opposite sign. I'm sorry, wrong one. Same sign. And then it flips, cosine of 45, and I'm going to squeeze it in here, sine of 30. So let's find those. Cosine of 30. So here's my 30 degrees right here. What's cosine? Rad 3 over 2, right? Oh, I'm sorry, 45. Oops. Sine of 45 is what? Rad 2 over 2 times, and then I want the cosine of 30. So what's that? Rad 3 over 2. Minus, I want the cosine of 45. Isn't that also rad 2 over 2? Times, and what is the sine of 30? 1/2. So again, don't we get the square root of 6 over, oops, backtrack to this. What mistake did I make over here that I just saw? What mistake did I make on this one? What's 2 times 2? Why did nobody catch that? This is a 4, isn't it? And this is a 4. So isn't this a 4? Sorry. So that means over here, I have rad 6 over 4 minus rad 2 over 4 equals radical 6 minus radical 2 all over 4. Oddly enough, I got the same answer. Here's why. If you go back to your sophomore geometry, and you look at, well, let's just look at this right triangle right here. These are complementary to each other, are they not? What's the sine of 30 degrees? Sine of 30. 1/2. Then look at the other degree and tell me what's the cosine of the other degree? 1/2. Isn't the sine and the cosine of supplementary angles the same? What's 75 and 15 to each other? They're supplementary. They're complementary. Did I say supplementary before? I'm sick. People, by the way, who's watching the video, I'm on my deathbed. I'm here just for pre-calculus. All right, so 75 and 15 are complementary, right? And so wouldn't it make sense that the sine of one is equal to the cosine of the other? So this one, the cosine of 75 is exactly equal to the sine of 15. Same answer. Makes sense. They reverse each other. All right, look at example 3. Am I going too fast?
No.
Okay.
Don't like the problem right now.
Well, because you're using something different, and you're not used to those sum and difference formulas. By the time you finish your homework, I hope you are. And when you look at your difference formulas, you'll notice that with sine, it reverses sine, cosine, and it's the same sign in the middle. These are exactly the same, but it's a minus sign in the middle. But with cosine, it's the same. Cosine first and then sine, but opposite signs from the middle. Still cosine and sine, but opposite signs. So that's an easy way to remember them. Tangent, it's the same sign, you add them together, but then down below, it's 1 minus them being multiplied together. This is the opposite sign from what's up here. These are the same, but that's the opposite sign. So get used to using them and identifying them, because when you look at example 3, haven't they used one of the sum or difference formulas? We have to figure out which one. Now cosine, if it were cosine, these would be the same. Same. But it's not, so it can't be cosine, right? Sine reverses these. Can't be tangent because they're not using tangent in here at all. So this has to be sine, and which sign is it? Is it the sum or the difference? It's the difference. And so that's all you have to do, because the 42 are the same, the 12 are the same. But if you look at this and you match it up to this one, whoops, I'll have to zoom out. If you match it up to this one here, we've got our sine, cosine, sine, cosine, sine, sine, cosine, cosine, sine. And then we've got a minus, and then we have a minus, same sign in the middle. So all you have to do, because it says express as a single sine, cosine, or tangent, that implies that this is equal to the sine of 42 minus 12. How do I know 42 comes first? Because we're not going to have a negative degree in there. And what's 42 minus 12? Sine of 30 degrees. There's your answer. So you might want to write yourself a note that this matches. The sine of u minus v. Where u is your 42 degrees and v is your 12 degrees. That wasn't so bad, was it? Like, I wish they were all like that one, right? All right, so let's go over to example 4. Now we're going to evaluate a trig function. You're going to find the exact value of the sum of the signs given, and notice that you have restrictions this time. That's where it becomes fun. So we were restricted here. What quadrant would that be? So this would be quadrant 1. From 0 to pi over 2, that's quadrant 1. And then this one's our restriction for the second one. What quadrant is that? From pi over 2 to pi is quadrant 2. Now, the first thing I'm going to do is I'm going to write these in the quadrants that they belong, and we are evaluating it for this right here. We're going to write out the sine of u plus v, so we're going to use that formula. But we have to find, these are not in radian form, nor are they in degree form, right? They're the ratios. So we're going to have to use Pythagoras Theorem or hope that it's a Pythagorean triple and our special right triangles to find what's missing so we can use our sine and our cosine. So step one. Oh, step one. I'll use green. So I'm going to use my quadrant here. Just set it there. Thank you, my dear. If I'm in quadrant 1, then here's where my reference triangle would go. Agreed? And I'm going to put a U here because that's what matches this letter here. By the way, this one's supposed to be a V. Please change this one to a V as in Victor. Otherwise, it won't work out properly. All right, so I'm putting U here because it's my reference angle name. And then they gave me that the sine was 4/5. Isn't sine opposite over the hypotenuse? So shouldn't 4 be over here and 5 be on my hypotenuse? You can either use Pythagoras Theorem or recognize that this is a Pythagorean triple. It's a Pythagorean triple, isn't it? What should that one be? 3. And it's a positive 3. Pay attention to what quadrant you're in. Everything in that quadrant would be positive, right? Now, we'll come back to that. Then let's go ahead and look at step 2. So we use this for step 1. And then for step 2, we're going to draw a triangle for this one. This one's in quadrant 2. So I'm going to draw my reference triangle into quadrant 2. And here is V as in Victor. There's my angle name there. This time they've said it's negative. Is your hypotenuse ever negative in your right triangles? No. So I know the negative belongs to 12 because this is adjacent over hypotenuse because it's cosine. That means that this is negative 12 and this is positive 13. So if you don't recognize that as a Pythagorean triple, then you need to use the Pythagoras Theorem. Does anybody know what that is? Do you know your triples? Yeah, she knows her triples. It's 5. And so this is a positive 5 because it's on the positive y-axis. Or you can use Pythagoras Theorem. So if you need to in your notes, circle that right here and say, find using Pythag Theorem. So now I've filled in my reference triangles. Question?
How did you know that it would be in quarter 1?
Because look at the restrictions that I've got highlighted there. This says between 0 and pi over 2. So this is 0 here, and this is pi over 2. So I know it has to be in there. And then this one says from pi over 2 to pi. So there's pi over 2, and there's your pi. So it's a good question. We have to know where we're at. Draw your triangle in the right spot. Okay. So then step 3, we're going to do the sine of u plus the sine of v. Okay? So the sine of u plus v is equal to, write out your formula that you see above. Isn't that the sine of u cosine of v plus cosine of u sine of v? Now we're just going to replace what we see. Sine of u, here's u. What's the sine? Yeah, and they had given that to us, right? So 4 over 5 times, what's the cosine of v? And they gave that to us also. We wouldn't have had to use this, but negative 12/13 plus cosine of u. Well, this one they didn't give to us, and that's why we did all this. So the cosine of u is adjacent over hypotenuse. Wouldn't that be 3 over 5 times this sine of v? They didn't give that to us, so that's why we did this. Opposite over hypotenuse is 5 over 13. So multiply. 4 times negative 12 is negative 48. 5 times 13 is what? 65. Plus 5 times 3 is 15 over 65. So since they have the same denominator, can't you do negative 48 plus 15? What does that give you? 33 over 65. That is your answer. We don't know what the angles are. Now, could we find the angle measures by using trig, sine, cosine, or tangent? Yes. It's probably going to be a funky number. All right, but this, we found the ratio. We were given ratios. Our answer is in terms of the ratios. All right, look at the back. This one says find all solutions of the sine of x plus pi over 4 plus the sine of x minus pi over 4 equals negative 1 in the interval from 0 to 2 pi. But notice that that interval, does it include 2 pi? No. So it comes up to 2 pi. So we've got to use two different, we've got to use our sine sum and our sine difference formula. And let's go ahead and just write those out as they are. So the sine sum formula would be sine of x cosine of pi over 4, and these are times. Same sign or different signs? Same sign. But then we do the cosine of x times the sine of pi over 4. And then plus, be careful if this is a minus in here, because then you'd have to subtract all of this and you'd have to distribute a negative. So do be careful. That could be on your homework. So I'm going to put plus there. Then for the difference one, we'd still do the sine of x times the cosine of pi over 4, but minus the cosine of x times the sine of pi over 4 equals negative 1.
Is it not negative pi over 4?
Say that again?
Is it not negative pi over 4?
No. She asked, is it negative pi over 4 here? No. That negative doesn't affect it. Now, which one of these can we replace with something? Do you know what the sine of x is? Do you know what the cosine of pi over 4 is? Pi over 4 is 45 degrees, and what's the cosine of 45 degrees? Rad 2 over 2. So then I can replace this with sine of x times radical 2 over 2 plus cosine of x times radical 2 over 2 plus sine of x times radical 2 over 2 minus cosine of x times radical 2 over 2, because the sine and the cosine of 45 degrees is all rad 2 over 2, isn't it? Equals negative 1. Now look at these as all one thing. Are there any like terms that you can see? Any ones that are alike, exactly alike? So I've got sines of x, right? These two are alike. And then these two are alike. What do you notice about these two? Ah, they're opposite signs. Can't this entire thing cancel with this? Let's cancel them out. Then, don't I have two of these that are exactly alike? So don't I have 2 sine of x times radical 2 over 2 equals negative 1. Do you see why I did that? Is everybody okay with that? Can I put that over 1? Don't these cancel because it's all multiplication? Do you see where I'm headed with this? Now I have the sine of x times radical 2 is equal to negative 1. How do you solve for sine of x? Divide by radical 2. So sine of x is equal to, and I'm going to leave it unrationalized because we're going to use our special right triangle. Don't we recognize that that's one of our special right triangles? So for here, I want to leave it unrationalized. Now, sine of x is negative. Where is sine negative? All students take calculus. it's here, right? So we're going to put in a reference triangle here and a reference triangle here. And then this is my x, and this is my x. Remember, your right angle goes perpendicular to the x-axis always. So then just choose one of them. It really doesn't, well, it doesn't really matter which one. So let's choose this one. So sine is opposite over hypotenuse. My hypotenuse is not going to be the negative. Isn't this part my negative? My opposite is -1. My hypotenuse is rad 2. What goes here that's missing? 1. X is across from 1. Don't worry that it's -1. What degree is x? X is, right, because this is a 45, 45, 90 triangle. So x is 45 degrees. But, and we want that in radians, so x is pi over 4. But that's not really our answer, is it? Because pi over 4 is in quadrant 1. What's the pi over 4 equivalency here? What's 4 pi over 4, because that's pi, plus a pi over 4? 5 pi over 4. So our actual x is equal to 5 pi over 4, because that's what's in quadrant 3. And then this is 2 pi, times 4 is 8 pi over 4. What's 8 pi over 4 minus 1 pi over 4? It's 7 pi over 4. But remember, you were supposed to memorize those. That's really our answer. Isn't that similar to what we did in 5-1, 5-2, 5-3? Well, wasn't that fun? Last one. Now, I will agree with you that I think you should be given the cheater sheeter. Okay? Because you're sitting there thinking, this is a whole lot of stuff to memorize. I've been there, done that. And I cried and whined and pitched a fit and said, well, in the real world, I'd be able to look them up. Well, here's the problem. Guess what your calculus teacher and your college professors expect you to know? All of this. They don't expect you to be able to look them up. And especially those of you going on to calculus as a senior, so if you're a junior right now, you're going on to calculus as a senior, this is one of the biggest complaints that your calculus teachers have, is that you don't know these. You don't know your co-identity. Ask Nelson. Just ask her. Ask her. She will say that's her biggest complaint from her calculus students, and you don't know them by heart. So as painful as this is to me, from me to you, because I whined and cried about it too. I'm like, this is ridiculous. I don't care what the other pre-calculus teachers do. I am not giving this to you on your test. Sorry. Learn them. Remember, I know, I'm sorry. But your calculus teachers will thank me.
What if we all have another one of those tests where we all get 27% on it?
It's not going to happen. Don't you worry. Let's do the last problem before you start to stress. Okay? Here we go. What if Kenny's, well, if its and buts were candy and nuts, we'd all have a wonderful Christmas if you celebrate Christmas. So you can if and but yourself to death. So now, before you stress, last question.
I
know.
I TA for her calc class.
Is that what she complains of? Thank you, Amber. So you tell her Mrs. Murray is making it painful.
Yeah, but you like that.
You tell her that tomorrow. You tell her that tomorrow. Murray is not letting them use the cheater sheeter that every other pre-calc teacher that their kids use. Cheater sheeter. Okay, here we go. Now we have this equals this. We have to prove. That means we have to come down to sine equals sine. So what are we going to do with this? Well, you're going to use, where'd it go? In front of your notes. You're going to use your cosine, right? I know, okay. Here's what Caitlin says. Well, this is one of the co-functions that we learned, but you have to prove it. Here's the difference. I know, we have to prove it. She's like, well, can't I just go sine of x equals sine of x? I'm done. No, you can't do that here because you're proving it. Remember, in a proof in geometry, you couldn't use what you were proving, the theorem that you were proving in the proof. So that's the theorem that we're proving in here, is that this co-function is equal to that. And we can't use that in here. I know. Just like, darn it. All right, so cosine, remember, it goes cosine, sine, and then it reverses. And is the same? Is the sign inside the same or different? different. All right. So, oh, I'm sorry, cosine, it's cosine, cosine, sine, sine. Remember, I'm sick. My brain is not functioning today. All right, so cosine of pi over 2 times cosine of x. Same thing, right? Opposite sign plus sine of pi over 2 times sine of x equals sine of x. Don't forget the right side of your proof. Look at your cheater sheeter. Well, your notes. Look at the other side.
Oh, okay, I get it.
Sine, it's got the same sign. Cosine, it's got opposite signs. But the cosine is the same thing, whereas sine is sine, cosine, and then cosine, sine. Does that make, I know. So we just have to memorize it. All right, so then from here, can't I find the cosine of pi over 2? Pi over 2 is one of our north, south, east, west directions on the unit circle. So we're going to take out the unit circle from our brain and look at the ordered pairs. So I only need pi over 2, don't I? And this ordered pair is 0, 1. This is all I care about. Cosine is it the x or the y on this ordered pair? The x. So cosine of pi over 2 is 0. So I have 0 times cosine of x, I don't know what that is, plus, what's the sine of pi over 2? 1. So it's 1 times, I don't know what sine of x is, equals sine of x. I'm losing my voice. What's 0 times cosine of x? 0. 1 times sine of x? Done. That wasn't so bad, was it? It made it look like it was more difficult, but it really wasn't that bad. Any other questions?